sessions. So the recordings will be available to you once the workshop is over. But first, good morning. Welcome to the Data Analysis in R week of the Summer Research Methods Camp. My name is Jake Thompson. I work in the Achievement and Assessment Institute as part of the Accessible Teaching, Learning, and Assessment Systems Center within AAI at KU. I'm a senior psychometrician. I work primarily with educational assessment data, but really what that means is that I live inside of R every day. So I'm really excited to talk to you all this week about how you can use R to analyze and learn from your data. The materials for this workshop, before we really get into it, are built on top of the materials that have been used for other courses taught by Hadley Wickham, Amelia McNamara, Charlotte Wickham, Garrett Grolman, and Allison Hill. So shout out to them. And at the very end of the week, we'll talk about some additional resources to learn more after this workshop. And you'll see their names come up a lot for these additional resources. Just some Zoom etiquette. I know we're probably all very familiar with Zoom by now, but do try to mute yourself when you're not talking. If you do turn your video on, make sure the background is appropriate. And then please do use the chat for the Zoom meeting to ask any questions. If there are any problems that you're having, like if Zoom stops working for you, or if you can't see my screen, or I forget to unmute myself, please let me know. And you can also raise your hand in the Zoom meeting if you have a question that you think would be better to talk about with the whole group. All right, so I just want to start with an overview of what we're going to be covering this week. So the first half of the week is really going to be how to work with your data in R. And then in the second half of the week, we're going to talk more about different modeling strategies and really learning from your data in R. So that's the general overview of how this week is going to go. So the first half of the week, we're going to talk about visualizing your data, how to transform it, so creating new variables from existing data that you might have, tidying your data, so getting in a format that's easier to work with, or at least easier for R to deal with. And then the second half is really going to be about making predictions, making classifications. We'll talk a little bit about sampling and resampling methods and some ensembling. So we'll do a little bit of machine learning at the end of the week as well. And in R, what this means is that the first half of the week is really going to be focused on a suite of packages called the tidyverse. And we'll talk more in just a little bit about what packages are. But the first half is going to be focused on what's called the tidyverse. And then the second half of the week, we'll be using the tidy models suite of packages. And there's going to be some cross-pollination there. So like in the second half of the week, we'll still be using tidyverse packages because the tidy models is built on top of that. But in general, the focus in the second half will be on the tidy models. So there are a few books that this is going to be based off of. The first is R for Data Science, written by Hadley Wickham and Garrett Grolman. So there are their names again. This is a really good book that is available for free online, which talks a lot about how to work with your data in R. There is a second book called Tidy Modeling with R, which is currently under development, which is why there is no book cover here. But it's written by Max Kuhn and Julia Stilge, who are two of the main developers for the Tidy Models packages. That book is also available for free online. And so you'll see it come up a few times throughout the course. And even though it's still in development, you can access the parts of it that are complete online. And then the last one, we're not going to talk a whole lot about R Markdown this week. You will kind of get exposed to it by necessity or maybe by accident. But we won't talk in detail about it, but this is a really good book to learn more about R Markdown if you're interested. But you'll see these resources again at the end of the week. All right, so a little more detail for this, what the schedule is going to break down this week. So today we're going to start with an introduction to what R is and what RStudio is. I don't assume that anyone has a lot of R experience or necessarily any R experience. So if you are familiar with R, this morning might be a little bit slow, or at least a refresher of things you already know. So feel free to tune out a little bit if you're already familiar with R, but we will talk briefly about what R is and how to use RStudio. And then later this morning, we'll get into data visualization with the ggplot2 package. So you'll learn all about how to visualize your data with different types of plots that look very nice and quite professional, actually. And then this afternoon, we'll focus on transforming data with the dplyr package. And you can see that we do have morning and afternoon breaks built in. So around 10:15 and 2:30, we will take a short 15-minute break, and then we do have an hour-and-a-half break for lunch every day. And then at the end of the day, from 3:30 to 4:30, I am hosting office hours, which do have a sign-up required. There was a link in your welcome email that went to where you can sign up for office hours. And these are really just meant to be one-on-one time where you can ask questions, get clarifications. If you have a specific problem that you're wanting some advice on, I'm happy to weigh in on how to do some of this stuff in R. So it's kind of your time for whatever you would want it to be. And you can sign up for 20-minute time slots every afternoon this week. All right, so then on day 2, we'll step back a little bit and kind of go into how R works. So we'll talk about different types of data in R. We'll talk about how to get your own data into R with the readr package for importing data. And then tomorrow afternoon, we will talk about the tidyr package, which is really about how to reorganize your data so that it is in a nice, consistent format that R is going to be able to use for all of its modeling work, which we'll then do in the second half of the week. On day 3, we're going to start with a case study. So this is going to integrate the 3 main packages that we're learning in the beginning of the week. So tidyr, dplyr, and ggplot2, we're going to kind of put all of those together into one case study where we're trying to analyze some data. And then later in the morning, excuse me, and in the afternoon, we'll start looking at the tidy models suite of packages. And specifically, we're going to look at the parsnip package, which is used to fit some different types of models. So in the morning, we'll start with prediction, which really just means linear models. And then in the afternoon, we'll talk about classification. So we'll talk about logistic regression, some random forests a little bit, and maybe a few other models as well. On day 4, we'll start with some resampling methods. So we'll talk about bootstrap sampling, v-fold cross-validation, what those are, why they might be useful to you as you're working with data, and how they can help us pick appropriate models. We'll talk about some model ensembling. So that'll be where random forests come in. That'll be in the late morning, the afternoon. And then in the very end of the day, we'll talk about modeling pipeline. So how can we put all of our modeling stuff we've learned so far into a single workflow that's easier for us to manage. All right, and then finally on day 5, we'll talk about some feature engineering with recipes. So that's how you can kind of extract some additional features from your data that are useful for modeling. We'll talk about tuning your models. So some of the models that we'll be working with have hyperparameters that can't be learned through the model estimation process. So we'll talk about how to pick what those parameters should be. And then in the afternoon, again, we will have another case study that kind of takes all of the modeling stuff we've learned so far and puts it into one data analysis that we'll walk through. And then the very last thing we'll do at the end of the week is talk about how to get help with R. And that's going to introduce the RepRex package, but we'll talk about additional resources for where to go next, where to go if you have questions as you're working on things in R, and hopefully setting you all up for success after this course is over. So again, the office hours are available every day, so please sign up for them. For questions, problem solving, consultation. The link is here. It's also in the email I sent out and on the course website. And so once you go to that link, you'll see a page that looks like this. You can pick which day you are interested in and your time slot that you would prefer. Does anyone have any questions about the course? Anything specific we'll be covering? Anything at all? Was everyone able, probably should have started with this, was everyone able to download R and RStudio before now, I guess? Was everyone able to do that over the weekend? Awesome, seeing some thumbs ups and some yeses. That is what I love to see. All right, so we are going to switch to our next slide deck. So this is my dog, Larry. You'll get to see him every time I switch slide decks. Okay. All right, so we're going to start with just an overview of R and RStudio and how they fit into kind of the overall data analysis, data science type of pipeline. All right, so when you think about data science or really just research in general that we all do, it usually follows like this sort of cycle where we form a hypothesis, we then design an experiment, collect data, and we explore our data, maybe run some tests, and then finally we're communicating the results. And that all kind of loops back into, okay, well, now that we have these results, maybe we'll form a new hypothesis. And it all seems like very simple when you put it in just like a little circle like this. But as we know, like it's not this simple. There's a lot of steps in between and where things can go wrong. And so really the circle looks more like this. So you like form your hypothesis, you get your experiment, you collect your data, but then you can't just like explore or test it. You have to put it into some software. You have to maybe clean your data. Depending on where it comes from, it can get really messy and not always clear how you should be looking at it. Once you start exploring your data or testing it, you might need to transform it or write your own modeling code or algorithm. You have to know how to visualize your data in whatever software you're using. And then when you're communicating your results, you're either maybe building an application, writing a paper. You then have to know how to deploy the app or publish the paper online. So there's a lot that goes on, and R is really focused on these yellow blocks here. Like, how can we make these parts of the process easier, more reproducible, more efficient? And so that's what I'm hoping we can do this week, is look at how we can make this circle a little bit easier for everyone. And I know that it can feel like we're climbing a mountain trying to do this, especially if you're not familiar with R, or maybe you're not familiar with any type of programming language. That's totally fine. But it can seem like this really big undertaking. And the overall goal of what we're trying to do is we have our thoughts, like what we know we want to happen, and trying to put that into a language that a computer will understand and execute for us. And so there are a ton of programming languages that all do better and worse jobs at this. So for example, C++ is like much closer to like how a machine thinks, whereas R, the way the functions are written, the way the language works, is a little bit closer to human thought, in terms of like just being able to write code that is expressive and clearly communicates what you want to do. R gets a little bit better than that, but it's not perfect. Like you can see there's still like a good chunk of space between maybe how we think and how we would normally express ourselves, before we get to where R is. And so the tidyverse, and the software developers who work at RStudio always talk about making a pit of success. So instead of a mountain that we're trying to climb, these packages hopefully, like we kind of just like fall into success, and it feels easier. And so the way that we do this is through our packages. And so a package contains different functions that'll do stuff for us. It might contain some example data sets. It has help pages, documentation, and all of that gets put together in a package. And some of those come with R. Just like as you install R, there are some functions built in. So if you think about it kind of like, the analogy I normally use is like a cell phone. Like if you go buy a new iPhone, there are some apps that just come with your phone on it, and these are the base R packages. But just like you can install additional apps on your phone, you can get additional packages for R. Some of these are going to improve functionality that already exists on your phone. So maybe you download a new email app or WhatsApp instead of iMessage. And some packages will do entirely new functionality that doesn't exist on your phone without it. So like if you download some games or TikTok or Instagram, like these are not things that your phone will do on its own. You can download apps that will do them. Similar for our packages, we can download packages to give ourselves functionality that doesn't come just with base R. And so the tidyverse is a suite of packages that tries to move us closer even to that human thought side. So we can hopefully just like type what we're thinking, type what we want to happen, and it will work. But you can see that like it's not going to get all the way there. Like it's always going to be a programming language. There's always going to be a little bit of a barrier between what we want to happen and what the computer is actually going to do. So my goal for this week is not to create a pit of success. Like we will never get there, but what I'm hoping is we can have like a gentle hill of striving as opposed to what seems like a mountain that we'll never get to the top of. So that's what I'm hoping to get to this week. So to use packages in R, the first thing you have to do is install them. You can do that with the install packages function, and that function is built into base R. And so this is what you did to install the packages from the website. You use install packages and you can list all the packages you want to install. And you only have to do this one time per computer. So like once you've installed a package, it's there and it's good to go. Just like when you install an app on your phone, it's always there for you. You don't have to keep installing it every time you want to use it. Then to use the package, you call library and then the package name. And this will load your package and tells R like, hey, I want to use the functions that are inside this package. And this is where my phone analogy kind of breaks down. But how I try to make it work is like every time you want to use an app on your phone, you have to like actually press it. Like I can't just use Instagram from my home screen. I have to like press it. And so that is my equivalent to the library call, which I acknowledge is like not great, but that's what I have. So that's what I'm going with. All right, so when you install the tidyverse, like the tidyverse really is just like a meta package that like wraps up a bunch of different packages. So when you do install tidyverse, you're really installing like 80 some packages or what's inside the tidyverse. As you can see a list of some of them here. We will talk about probably most of these that are listed here throughout the course of the week, and some will go into a lot more detail than we will for others. But there are a ton of packages in the tidyverse, many of which you might never use because they may not be applicable to your area of study or particular data projects you're working on, but they all are there. And then when you call library for the tidyverse, it's going to load just these 7 or 8 packages. And these are what's called the core tidyverse. So these are packages that you will probably use a lot as you're analyzing data and will be very useful for you. The other ones that are not part of the core tidyverse are really more specialized, and those are the ones that may or may not be applicable to you, depending on what you're doing. So ggplot2 is going to be our data visualization library. So we'll talk about that this morning. For visualizing data, Tibble is how data is going to be stored in R. And so we'll talk about Tibble a lot tomorrow when we talk about importing data. tidyr is for tidying data. So how can you change rows into columns, columns into rows, that sort of thing. readr will be for importing data. Purrr is more programming. It's a little, we'll talk less about Purrr than some of these other ones, but we will touch on it for a little bit. dplyr we'll talk about this afternoon. That's really data manipulation. And then the last two, stringer and forcats, are tools that are used for working with character type data, factor variables. We'll talk about those tomorrow morning when we talk about different data types. So those are the major tidyverse packages that we'll be talking about. And those are the core tidyverse that'll get loaded when you call library tidyverse. All right, so instead of that circle we saw at the beginning, I like to think about like applied data science following like this sort of flow chart. So we'll import our data, tidy it, and then we kind of go through this iterative process of visualizing the data, maybe fitting a model, transforming the data, looking at a new visualization. So we kind of iterate through this process until we find what's going to work best to answer our specific research questions. And then somehow at the end, we will communicate out the results. And then like around all of this is programming, which influences how we can do some of this work and can make different steps of it more efficient depending on what it is we're doing. And so especially the first half of this week, we'll go through almost each of these different parts individually to talk about how we're going to do each of these steps in R. And then again, that case study is kind of wrap all this together for us. All right, so that is R at like a very high level. So now we're going to move to RStudio, which is our interface to R basically. So RStudio is a software program. It's an IDE, which is an integrated development environment. It's going to help us write code, run code, and analyze data. It is a lot of things. It is primarily a text editor, which is what we need for R, but it can also help you with version control if you want to use Git or GitHub. It has some debugging tools, so if you're writing some R code and it thinks something looks wrong, it'll let you know, which is helpful. And it does a lot more, and some of that stuff we'll talk about as we go through the week. All right, so these blue screens mean that it is your turn to do something. And so where I want to start is downloading all of the course materials. So there are a couple ways that you can do this. The first way is from R. You can run this little section of code, and it will download a zip file to your desktop or wherever you want to, or you can go to GitHub, this link here, hit the green code button and download a zip file. Once you do that, we will open the zip file, and there'll be something called tidyds 2021.rproj. That's an R project. We will talk about projects a little bit later this week, and why they are useful and why you should use them. But for now, just know that we're going to open that to open the project. And then in the files pane of RStudio, you can navigate to this file, materials, the exercises folder, and then O1 getting started. So I'll give you all about 5 minutes to do that. And then if you need more time, or if you're getting done early, feel free to give me a thumbs up or put in the chat that you are ready to move on. All right, does anyone need extra time? This is, what was it? Oh, so as you might be aware, this is the first time we've done this course over Zoom, like entirely virtually. So usually it's much easier for me because I can just look out over the room and like see who's still working and who is done. So that is going to be a little bit of a challenge this time around since we're not all together. So I will probably be relying on you all more than I normally would to let me know if you do need more time. Otherwise, I will just keep going. I don't want anyone to get too far behind and need to catch up. All right, so does everyone, when you open RStudio and you open the project, you get a screen that looks kind of like this. So you'll have these like 4 different panes that have stuff going on in them. So we'll talk about what all of these different things do. It looks like we might need 1 to 2 more minutes for a couple people. So I will talk slowly about kind of like what RStudio does and what it's looking like while people finish up downloading the course materials. And actually, while we wait, I'll just pull up my RStudio. So I'll be switching back and forth throughout the week between the slides and my own RStudio to kind of do some coding along with you. So if you were able to open up the project, you probably in your little files pane over here see what's inside this project. And if you go to materials, exercises, and then this O1 getting started, that'll open up this file, which we'll talk about in a little bit. And so this is like what RStudio looks like by default. I will be honest with you that I do not care for it. I am very much a dark mode person. So you can change how RStudio looks. So if you go to, and I'm just going to do this now because it'll drive me crazy if I don't. If you go to global options, you can change how RStudio behaves and how it looks. And so I would encourage you to play with these different options to see what works for you. If you have questions about them, I have a lot of opinions on things. So I am happy to tell you what I think good options are. But I'm going to change my theme to a dark theme. So my RStudio is going to look like this all week. So it may look different than yours if you choose a different theme or if you keep the default theme. But even though it looks different, it's the same thing. So this is what you'll see on my screen during the week. Question in the chat. When you install the packages, is it always there or do you have to call it and never reinstall them? You do not need to reinstall them. So like here in my console, I haven't done anything. Like if I just do library tidyverse, it's going to load the tidyverse and it's all there. I didn't have to install it because I've already installed it on my computer. So once it's installed, you just have to use the library to let your R session know that you're going to use those packages now. Good question. All right. So there are 4 panes. You only see 3 on mine right now because I have zoomed in a lot to make sure that you all can read the text in my RStudio console. If I need to make the font bigger, please let me know and I can zoom in some more. So I only have 3 panes open right now. So in your bottom left, if we go back to the slides, you probably have the console. So it's just like this little arrow. there's nothing really there. You might have like some welcome language from R. If I switch back like this, like you probably have like some welcome language. Like this is my console. It'll say console at the top. And this is where you actually run the R code. So you'll put your functions there, make the font bigger. I can do that. Is that better? Good. Yes, awesome. All right, so the console is where you will execute R commands right away. You can get help from the R console, which we'll talk about. But that's what the console does. Your other pane, which is probably in your bottom right, is going to be some navigation stuff. So there's a files tab where you can see all the files that are in your current project. You can see the help pages under the help tab. So if you have questions about packages or functions, you can go to this help tab. And then from the help tab, you can see if this works. There's like a little search bar. You can type in exactly what you want help on. It'll pull up the help page down here for it. This tab or this pane is also where you'll see your plots. So just in a little bit, when we start making some data visualizations, your plots will show up in this pane down here. And we'll also talk about how to save those so you can get them outside of RStudio, but this is where they'll be popping up. In your top right pane, if you have the defaults set, is where you will have a few different tabs. This one that's highlighted here is called the history tab. That's going to show you all of the R commands that you've run recently. So if you have a plot down there and you say, oh, I don't remember the code I used to make that plot, you go to the history tab, it'll show you all the different commands that you've run. And the environment tab is the other one that will be useful to us. And that's just going to show you all of the different data objects that you have currently in your environment. So like if I go to my RStudio, the way I have it set up so you all can see, I have basically like all my stuff's down here. But if I go to my environment, it's empty because I don't have any data loaded right now. But we'll see how that changes as we go through the week. All right. And so then the last pane in your RStudio window is going to be where your scripts go. So like when we are opening our exercise documents, this is where they will appear. And for us, these are going to be our Markdown documents. So we're not going to talk a whole lot this week about our Markdown or how our Markdown works, but you will get kind of exposed to it through our exercises. And so the R Markdown documents have these different sections to them. So you'll see that there's like this kind of like metadata up at the top between these like 3 dashes at the top and the bottom. That's just some information for R to know like what this document is, how the output should be put out. If we were to like fully render it, that sort of stuff is what goes in the metadata. You won't need to worry about any of that this week. I've already got it all set up for all of our exercise documents. Then there is some text. This is just like normal writing that you would have. For us, that's going to be the instructions for the exercises. So it'll say like, do this, then do that. And it'll basically be what's on those blue slides. So you'll have the instructions in two places. Then you'll see these like different shaded areas. And these are our code chunks. So anything that is between these ticks, like there's 3 ticks at the beginning and then it's R so that it knows it's R code, and 3 ticks at the end. And then anything between here is your code. So this is where I'll have like some template code sometimes that you will be changing, or it'll just be like an empty block that you'll be writing your own code in to work on the exercises. But this is where your actual code will go. And once you write your code, you can click the little play button that will run all of the code that's within this chunk. And then the output of the code will be shown right below it down here. So like this code is generating like 7 random numbers from a normal distribution. And so those 7 numbers pop up down here below it. And so that's generally how an R Markdown document is structured. It's some text, and then it's some R code, and then it's some more text, some more R code. And so that's how our notebooks are going to look. And you can also, the last button I will mention is this, like the down arrow with the green bar. That will run all of the code chunks before this code chunk. So if you get a little bit behind, or you just want to make sure that everything is up to date, and we're on like exercise 7, you can hit this button and it'll run the code for exercises 1 through 6. And that way you'll know you're up to date. All right. So that is at a high level, like what's going on with R and RStudio. There are a couple other things that I want to point out in our specific project before we keep moving. In our files, there are like 2 main folders going on here. Like everything you will need is in this materials folder. The site folder contains all of the code and documents that make the course website. So you don't need to get into there, but if you're interested, like that is available to you. But in the materials, all of the exercises are in this exercises folder. So you can see everything that we're doing from getting started. Will be in the visualize document later this morning, and the transform exercises this afternoon. All the way through the end of the course, all the materials are there. There's a data folder, which is going to have some data that we'll use for a few of these exercises. We'll talk about that more tomorrow. There are also some solutions, and by some solutions, I mean all the solutions. So like as we're going through the exercises, like we'll talk about the answers together as a group, but they're also available to you, so you have the answer keys as your own reference for after the course. That being said, like there's nothing stopping you from opening the solutions as we go through this and just seeing the answers for the exercises. But I would encourage you to try not to use them. I really think like going through the exercises, actually writing the code yourself instead of just copying and pasting it will really help you learn. But all the solutions are there, so you can see that there are the working code for all of the different things that we'll be doing this week. All right, does anyone have any questions about R, RStudio? We'll be talking obviously a lot more about R. We'll talk less about RStudio. It'll kind of just be our tool that we're using as we go through this. But if you have questions about how to do something in RStudio, I'm happy to talk about those as well. Nope, not seeing anything. All right. So it is almost 10 o'clock. So we are scheduled for our first break to be at 10:15. I'll kind of leave it up to you all right now, whether you would prefer to take a 15-minute break now and then jump into data visualization, or if you want to do 20-25 minutes on data visualization and then take a break, just kind of whether you want to kind of split up data visualization or get into that right away. So while you all think about that and weigh in, there is a question in the chat that I will try and answer. So R Markdown is a way to write or view your activity in a way that might make sense to others. My peers use R. Yeah, so I highly encourage people to use R Markdown for a couple of reasons. The first being that I think communication is a lot easier. So like if you send someone just like an R script, like it would just have this code in it. And that is like hard for someone to understand what you're doing. Like even like I work in R all the time, but like if someone just sends me an R script, like it takes me a while to figure out, okay, like what are you trying to do? What is this actually doing? Like what do I need to understand about this? Our Markdown is a way to mix like some just narrative text with your code. So like here, you can like describe in the text, like, here's what this code chunk is doing. Like that's not what this says, like it's just kind of describing what a notebook is, what our Markdown is. But you could say like, here's what this data is, I'm making this chart, here's what it looks like. And so like then I can go in and I can run this code chunk. It's going to make this plot. I see the graph. And then you can like kind of describe like, because the graph looks like this weird thing is happening. So you can kind of like mix your thoughts or your thought process along with the code and really describe what's going on. So yeah, that's exactly right. It integrates your script in any writing you want to do. So I really like our Markdown. I use it for almost everything. We're not going to talk a whole lot about our Markdown this week specifically, but you will be obviously using it for your exercises. Like all of your documents are, they are our Markdown. So yeah, you will get exposed to it and you'll know basically how to put one together just from using them so much. Great question. All right. So how does the group feel about a break now versus a break in like half an hour? No preference. All right. So I think we'll go ahead and take a break now. So that way, once we start data visualization, we can kind of just go through it. So we'll do 15 minutes. It is 9:55 Central Time. So we'll come back at 10:10 Central Time. All right, if you're back, go ahead and give me a thumbs up or let me know in the chat. Awesome. All right, so one thing I actually do want to talk about before we get into data visualization is just really quickly, I want to talk about the course website really fast. So this is the website that you all have seen. On the info tab, what will be most important is there's a link to book office hours if you want to do that. There is also the schedule. If you want a reminder of what the schedule is going to be for this week. But the most important is going to be the materials page. So this will get updated every day with that day's, we're going to talk about that day. So you'll be able to find all of the slides, all of the exercises and solutions will all be on this page. So like if you click on the data visualization exercises, that will take you to a copy of the file that you have in your project. So I wouldn't necessarily recommend like going to your exercises here because you can't actually run this code like you can in RStudio, but there are links to all of those there. And there also are the slides. So if you click on the slides link, it'll pull up a copy of the slides, which is really nice if you want to follow along in the slides. You can pull those up and follow along as we go if you would like to. And these resources will stay here. So once the course is done, all of the resources, maybe. Okay, well, it doesn't want to work anymore. But all of the resources will stay on that materials page. That's where the recordings will get posted up once the workshop is over. And so that will be there for as long as the internet lets me keep the URL. All right, so now let's talk about some data visualization. All right, so most of what we're going to talk about today comes from a book from Lucy D'Agostino McGowan, who's a professor at Wake Forest, called ggplot 2 and 2, which is a workshop that she originally put together to teach ggplot 2 in 2 hours. We have about an hour and 45 minutes until lunch. So we'll see if we can do it in an hour 45. If not, we can finish up after lunch and that's not a problem. All right, so for data visualization, we'll be using the ggplot2 package. And for more details about the ggplot2 package, how it works, some best practices, there is a link here to the data visualization chapter of the R for Data Science book. So would encourage that for some further reading if you're interested. So just to kind of orientate ourselves again, you'll see this graphic a lot this week as we talk about like where we are in the cycle. We're going to be like within this iterative cycle in the middle where we're talking about data visualization. All right, so ggplot2 is really powerful and it's used by a lot of different organizations. So here you can see some graphics from the BBC News and 538. These are both made using ggplot2. You can also do like some weird stuff, like maybe not weird to me because I don't do this type of work very often, but like network graphs can also be done in ggplot2. Here's an example from Kieran Healy. Also, you can do like heat maps. So this is looking at hourly temperatures. I think in New York is where this is from. But these are all made in ggplot2. So you have the power to make a ton of different types of graphs, all within the same sort of conceptual framework for how to put a graph together. So the GG in ggplot stands for the grammar of graphics. And so this was originally a book by Leland Wilkinson, which is here. And from that book, Hadley Wickham developed a layered grammar of graphics. The DOI to the paper is here, and also in your materials, I tried to put all of like these types of references for you. So like if you go to the handouts in your materials, not the handouts, if you go to the references in your materials, you'll find Hadley's paper here. So it is in your materials for you. If you want it, you don't need to read it unless you're really just interested. But he made a layered grammar of graphics, and that became ggplot. So this is the ggplot2 book. It is not available for free. However, they're currently working on a third edition, and the third edition is available for free online. It's not finished yet. It's a work in progress, but the link to it is here in the slides. So you can follow along with them as they work on it. And once it's finished, it will be at that link available for free. So would encourage you to go look at that for much more details about how ggplot2 works and how you can use it to meet your needs. But the theory of ggplot is you start with your data. And you're going to take your data, and that is going to map to aesthetics. And those aesthetics are going to appear in layers. And so all of these things kind of build upon each other. So rather than thinking about, I'm going to make a line graph or a bar graph, you're really thinking about layers and like what goes next on the plot. So it's really separate elements that go together. So you start with just like a blank canvas. And from that canvas, you can add geometric objects. And so the highlighting and bolding will become evident momentarily when we start talking about what the ggplot2 functions are. But for now, you add geometric objects. On top of that, you can add statistical transformations. You can add, for example, a linear regression line to your data. You can add position adjustments. So you can jitter your points a little bit. So it is, it's one way to help with overplotting. So if you have plots that are like here, scatter plots where the points are all on top of each other, you can jitter them a little bit so you can see each of your points. You can also add different aesthetics. You can map color to the group. So like one group here is yellow, the other group is blue. Or you can do facets. So you could split them out into like two separate little windows within the same plot. So you see just group one at the top and then just group two at the bottom. And finally, you can change theme elements. So here, like this is the ggplot2 default is this gray background, but you can change it. So this is what we'll learn in a little bit is theme BW for theme black and white. So you get the white background instead. So those are really like the main elements that we're going to talk about today for ggplot. Right, and we're going to use some example data to work through this. It's from the Bechdel test. So the Bechdel test is used for movies to look at gender balance, basically. And so the way that a movie passes the Bechdel test is it has at least two women that are named in the movie. The women have at least one conversation with each other, and that conversation isn't about a man. So very low bar. But as we'll see, there are a lot of movies that do not meet these criteria. But those are the three things a movie has to do in order to pass the Bechdel test. And so there are a couple ways that you can look at the output of the Bechdel test. There's like a binary pass fail, like did you meet all three criteria? Did you not? Or you can get 5 outcomes based on the severity. And so these are going to be the 5 levels that we'll see in our data. You can have no women in your movie at all that are named. So that would fail the first criteria. You could have women, but they don't talk to each other. That would fail the second criteria. Or they do talk to each other, but they only talk about men. So that would fail the third criteria. And those 3 would all be failing grades. The next level would be dubious, where the people who kind of report out on the Bechdel test disagree on whether that conversation is about men or not about men. And then the passing grade is okay, where it meets all of the criteria. All right, so to get this data, there's a package called 538. And so this package includes a bunch of data that's been used by 538 for the articles they write on their website. So if you load the 538 package, which you installed as part of your pre-work with library 538, then you can call Bechdel. You can just type Bechdel and you'll see this data set show up. And it contains a bunch of information about each of these movies. So you can see this has, let's see if I can get my little spotlight to work. It has the year that the movie came out, an IMDb identifier, so you could look up the movie on IMDb, the movie title, the test result, so you can see like which criteria it failed or if it was okay. You get this variable that's clean test, which is going to be the one we'll use, which is basically just test, but it's been cleaned up to make it nicer to work with. You have the binary pass fail. Did it pass all 3 criteria? Did it not? And then we also have some other information. So we have the budget for the movie. How much did it cost to make it? The domestic gross. So how much money did the movie make? The international gross. So how much money did the movie make internationally? And then some other data that is not going to be super important to us. You can see this is only showing us a few of these variables up top because the rest don't fit. But you can see the other 5 variables we have are the budget in 2013 numbers, so adjusted for inflation, how much money the movie made in 2013 dollars, a period code, so that's when the movie was made, so it's based on the year, and then a decade code, which is the decade the movie was made. And the ones that we're going to use the most from this are going to be this clean test column. So the result of the movie, we'll use the budget, the domestic gross, and then we'll use the decade code also to look at how results from the Bechdel test have changed across decades. All right, so the first thing you all will do is go ahead and open that visualize exercise in your project. Let's look at the Bechdel data set, and this code is in your exercises. Go ahead and run it, see what happens, and then we'll talk about what this code is doing.
Jake, are we supposed to write this into our console or?
Great question. So in your exercises, if you look at, so you'll want to run the setup chunk, but then when you get to your turn 1, yeah, you'll put that code right here in this empty code chunk. and then hit the play button, and it'll make the graph for you. Does that make sense on where you're putting the code?
I don't think so. I can't see the path at the same time, so I don't know where to go.
So in your files, like if you hit, do you have like this little R cube in your file path up here?
Yes.
So if you hit that, that'll take you to like the root of the project.
Mm-hmm.
And so from there, you can hit the materials folder and then go to exercises and visualize, and that'll open up our notebook for us.
Mm.
And then if you scroll down to your turn 1, excuse me. And then in here, we can type in that code from the slides.
And it goes underneath that R inside of those
Yep.
things.
The code always goes in between the tick marks. Yeah.
Okay.
And then once we have that code written, we can press the play button. It'll run the code and we get a graph that looks like this. Is everyone getting a plot that looks like what's on the screen here? Awesome.
Where can I see the rest of the code to write in?
This should be the only code that you need. Right? Or are you thinking that there's a different code?
I just can't type fast enough because you scrolled down, so I couldn't see it anymore. But
no worries, no worries. So there's a question, is there a reason the plot shows up in the markdown and not in the plots output? Yes, there is a reason. It is because we're in a HTML notebook and the chunk output type is inline. So that's why it is showing up inline. If we take that out, then we'll see if this works or not. But if we clear this and play it, nope, still shows up there. We can, in our markdown, so if you go to your options, if you go tools and your global options in our markdown, you can show equation and image previews. Well, it says during the viewer pane, but so maybe I just need to restart our markdown after I have changed that. We'll see if this works or not. Okay, so it's because we're in a notebook. If I change this to be like a HTML document, then it'll pop up over here. Or if you're just in a normal R script, it'll pop up over here. But it's because we're in a notebook. All right. So this is just the code again and the plot. So inline is the default for RMD files. Yes, inline is the default. If you're in a notebook, it will always be that way. If you were to change your output type to an HTML document, now we'll see if I was correct in my thinking. If I am not in a notebook and I run this, oh, it's still popping up. I think I need to restart RStudio in order to make it work, but I'm almost positive that if you're not in a notebook, it'll show up over here if you make it do that. I know it drives me crazy having the stuff pop up inline. I don't like it. So I've set up my settings to where it does pop up over in the plots pane. I changed, this was maybe not smart of me. I changed my settings before this workshop started back to the default settings so that my RStudio would look like your all's RStudio as we were going through this. And so now I'm not remembering how I got it to go over there, but there is a way to do it. And I know that if you're not in an R Markdown document, it will for sure pop up over here. So like I'll just, if I copy this, like I can go to a new R script that's not an R Markdown document. And now if I run this code over here, it does pop up over in the plots pane if you're not in an R Markdown document. All right. All right, so let's talk about like what this code is actually doing that we just ran. So the first thing is we're telling ggplot which data we're using. So here we're saying we're going to use the Bechtel data. And we're just defining like what data we're going to use for this. Then we have the plus sign. So we add the plus before the next line, and this is saying we're going to add some layers to this. Because if we just run that first chunk, we're just going to get that blank canvas again. And so then we define the type of layer that we're adding. So here we add geom point. So this stands for a geometric object, and that is going to be points for us. We're making a scatter plot. And then we define our aesthetics. So how are we mapping the data to this geometric object? And so AES stands for aesthetics. And in our aesthetics, we say that on the x-axis, our x variable is going to be mapped to the budget variable. And then we want to map the y-axis to the domestic gross. So how much money the movie made on the y-axis versus how much the money cost to make on the x-axis. All right, so let's talk about the aesthetics that we have at our disposal. There are a lot of them. So we can look at color, we can look at size, we can look at shape. All of these are things that we have control over within ggplot. So if we look at color, we might want to map the clean test variable. So at what was the test result for the Bechtel test for each movie? Map each of those results to a color. So we can add that to our aesthetics in our geom point function. So we say color equals clean test. So we're mapping the color to the clean test. Again, here's what that code looks like. And then if we look at the plot that comes out of that, we see our same scatter plot as before, but now each point is colored according to what the test result was. So it is really easy to add color to your plot, and you get a legend that is added automatically. All right. So now we have another opportunity for you all to kind of play around with ggplot and experiment a little bit. So what I want you to do is take that same graph code that we had for the previous exercise and just experiment with adding color to different variables, adding size, adding alpha, adding shape, and just kind of seeing what happens. And think about how the aesthetics behave differently when they are mapped to a discrete variable or a continuous variable. Or also what happens if you add multiple aesthetics. It's like we added just color in the last example, but you could do color and shape or color and size. So I'll give you all a few minutes to play with that, and then we'll come back and talk about more of these aesthetics in detail. All right, so I realized after setting you all loose that I did not actually give you all of the information you probably needed. So in addition to like these exercises, there are also some cheat sheets that I've provided um, that are created by the people who make these packages. Um, so in your files, and we'll talk about these a little bit more as we go on. In the handouts, there is a ggplot2 cheat sheet. And so if we look at this, it has a bunch of information about ggplot2 and kind of like different aesthetics, different geographical or geometrical objects that you can add. So this will be helpful to you as we go through the exercises. So just be aware that that cheat sheet is there as we go through, and you'll see there are cheat sheets for a bunch of the different packages that we'll be talking about this week. So was everyone able to play with some of these aesthetics a little bit and see what happens? Awesome. So if you play around a little bit, you'll see that some of them change depending on what type of variable you are setting them to. So if you set color to a discrete variable, it kind of gives you like 3 distinct colors or multiple distinct colors depending on how many there are. If you map color to a continuous variable, it gives you a gradient to go on. Size is less clear. So a discrete variable, it'll give you 3 distinct sizes, but it is not always clear that those are distinct discrete variables as opposed to the continuous variable. And similar for shape, if it's a discrete variable that you're mapping the shape to, you get different shapes, but you actually cannot use shape for a continuous variable because that doesn't really make sense. Like a triangle is not like greater than a circle, and a square is not greater than a triangle. So it actually will not let you do that. So just as you're putting these different things together in your own work, really think about what type of aesthetic it makes sense to map your data to. And we will play with more of these as we continue to go through these examples and exercises. All right, so we'll talk about now setting aesthetics versus mapping aesthetics. So what would we do if we wanted to just make all of the points blue? Like we're not mapping the color aesthetic to any particular data variable. Like we just want everything to be blue. So when we set the aesthetic, when we set color inside that AES function, it's going to map the color to a variable, in this case, clean test. If we set the color outside of the aesthetics, so here we've just set budget and domestic gross to the X and Y variables inside aesthetics. And then outside of that, we say color equals blue, then that's just going to set the aesthetic for everything, but not to a variable. So again, inside of aesthetics, we'll map it to a variable. Outside just sets a value. So yellow means pop quiz. So the question for you to think about now is what would happen if we tried to set color to a specific value, in this case blue, but we did it inside of the AES function. Does anyone have a guess as to what would happen? So we have a guess for an error. It will actually not throw an error. That is one of ours wonderful quirks is sometimes it throws errors when you don't want it to, and sometimes it does not when it probably should. All the dots will be blue. also not accurate. You would think that would be helpful, but it will not do that. So what happens is ggplot thinks that what you are trying to do is map color to a variable called blue. And because there is no variable called blue in your data, it makes one for you. So what ends up happening is you get a plot that looks like this, where it assigns a color, in this case, the first color of ggplot's distinct values. So if we go back to the aesthetic overview, you see that the first color that it uses is this pink color. So now, when we are looking at the plot, it's setting everything to like this pink color, and it's saying that like these all have the value of blue because that's what we set it to, which is not what we want at all. So if you get a plot that you say, I don't know what the heck is going on, like this is not blue like I asked for, check to make sure that you are outside of your AES instead of inside your AES, because that is probably what's happening. All right, so now let's talk about some geometries. So these are like really what's making up our plot. So how are these plots similar and how are they different? We can start by saying, well, they're both using the same data. Like this is all the Bechtel data. They both have budget on the x-axis. They both have domestic gross on the y-axis. But what's different here is the geometric object, which is like the visual object that's used to represent the data. So ggplot kind of has this template that you can think about. So we call it ggplot, we say what data we want, then we call like some geom function and then map the aesthetics to that. And so in the cheat sheet that we talked about a few seconds ago, there is an example of a ton of different geoms that are available to you. And these are by no means all of them. Like there are a ton. And so you can actually get a full list if you go to the, why does this keep happening? Okay. So if you go to the ggplot2 website, you can look at under layers, there are like all of these different geoms. Like there are a ton of different things you can do. We're going to talk about just like the most common ones. But if you're wondering like, can I make this plot in ggplot? The answer is probably yes. Like there's a way to do almost anything here. All right, so what I want you all to do now, in your exercises, there is this code, which makes this scatter plot that you see here. What I want you to do is edit this code to, instead of a scatter plot like this, to make a box plot. So you can use that cheat sheet, you can use Google, but try and figure out how to turn the scatter plot into a box plot. All right, was everyone able to get a box plot to show up? The way that you do this, oops, if my slides will go, is you just change geom point to geom box plot. And we wanted to map the clean test variable to the X, and then the budget to the Y. And so if we look at the plot that gives us over here, we can see that we have the test result on the X-axis, the budget on the Y-axis, and then we have box plots instead of a scatter plot. Was everyone able to get this to show up? Or if you use the code that's here, are you able to run that code to get it? Awesome, seeing mostly yes, which is good. And again, you do have access to the solutions in your project. So you can always get in there and run the solution code to make sure that that is working for you as well. All right, so now we have a similar exercise. What I want you all to do is try to make this histogram of budget. So we do have a question. The cheat sheet said F plus geom box plot. Good question. So the F is like a placeholder. So in the slides, like if we ran just geom box plot, like nothing's gonna happen because the ggplot hasn't been created yet. So you have to do like ggplot data, whatever your data is, plus the geometries. So that F is really just like a placeholder for like the step you have to do before geom box plot. So yeah, not super clear, but it's just a placeholder for like everything that comes before that. All right, so we'll take a few minutes here, try and create the histogram. All right, so there are a couple of things I want to talk about here. First, the question in the chat about the condensed numbers. So this is another quirk of like my own R setup. So if you're seeing like the condensed numbers, like the 1E plus 08, instead of like it all written out, what you're getting in your plots is scientific notation, which is the default in R. So it's totally fine. It's the exact same as what I'm seeing here, except that I have turned off scientific notation for my own R session. And so I tried to change all my settings back before I made these slides and these plots, but scientific notation apparently slipped through. I think I have some emotional scarring from high school chemistry that keeps me from fully embracing scientific notation. So if you're seeing scientific notation and you don't want to, how to turn it off? Yes, so it's actually very easy once you figure out how to do it. So in R, scientific notation is controlled by an option called SciPen. So if in your console you type get option SciPen, it'll say 0 presumably. And we're going to come back to this in just a second because I'll make the graph. So to make this plot, again, you start with ggplot, data equals Bechtel. And then the geom here is geom histogram. So as you're probably starting to discover, the geometries are named almost exactly what you think they are. There's geom box plot, geom point, geom histogram. They all are just kind of what you would expect. What's different about this particular plot is there is this count variable on the y-axis, and there is no count variable in our data. So how do we get around that? If you go to the help page, so if you go to help, we type in geom histogram, and this works for any of the geometries you want. It'll have like how the function is operated, the different arguments that go into it. And then if you keep scrolling down, eventually you will get to aesthetics. And it tells you that it computes, like geom histogram is computing these aesthetics for you. So compute count, density, all these different things. And so that is getting calculated for you automatically. So here we can just specify the X aesthetic, which is budget, and then it will automatically, where did it go? Oh, is it trying to go over to my plots pane now? Oh, no, okay. So automatically make this, and here you can see that I am getting like the scientific notation. So the way you can get rid of this, you set options. So earlier we did get option, now we're setting options. Say SciPen equals some large number. I always do 999. And then if you run this code again, your scientific notation's gone. So SciPen equals 999 is just saying like, don't use scientific notation unless there's like 999 zeros over there. I think that's actually like the maximum it'll let you set. So you're not actually like technically turning it off. You're just setting the threshold for it so high that it's effectively off. But yeah, SciPen is your greatest friend if you want to get rid of scientific notation. All right. All right. So again, there's the solution code, geom histogram. You only specify the X aesthetic, and then you get your plot. All right, so now we're going to experiment again. We now want to make a density plot. of budget. So again, we want budget on the x-axis, and we want to have that colored by clean test. So for each result of clean test, we want a separate density curve that has a different color. All right, so let's go ahead and play with this for a few minutes, and then we'll talk about the solution. All right, so let's talk about this one a little bit. So we'll start with just what you would need to make the density. So again, this is going to be geom density, as you might expect. Like histogram, the density is calculated for you automatically, so you only have to specify that X aesthetic. And when you do that, you get a plot that looks like this. And so that's going to be your density curve over all the movies, is what you get there. And then to add color, you again just add that color equals clean test aesthetic. And it will then create a different density curve for each of the different levels of clean test and give them each a color. Any questions about how that worked? No, all right. So I think we have a couple more of these kind of experiments to play with things. So the next challenge is to create this bar graph. So again, we want the clean test on the x-axis, the count of how many films there are in each category on the y-axis, and then color those bars so that each outcome of clean test is a different color. All right, did anyone get tripped up by this one? So if you very reasonably thought that you can do geom bar and set the color to clean test, you got something that looked like this, which is not what we were hoping for. And what happened was it just put the color outline around each of the bars. So there's actually another aesthetic called fill. So if you do fill equals clean test instead of color equals clean test, then you get each of the bars that are filled with the correct color. So that might seem annoying, and you would not be wrong, but that's helpful if you have a bunch of bars and wanted to have a color and an outline. So for example, if we wanted to put a black outline around each of these bars, we could do that as well. So it is the fill aesthetic was the one that you were looking for here. All right. So now what I want you to do is, I don't think we need 5 minutes for this one, but think about what this code is going to do before you run it. Like, what do you expect to happen? And then run it and see what happens. So we'll do just a couple minutes here since the code I think is already in your notebook, and then we'll come back and talk about what's happening. All right, so what's happening here? We, instead of our previous examples, we now have two geometric objects, right? So we have our geom point, and then we've also added a geom smooth, again, with budget on the X and domestic gross on the Y axis. And so what happens is that we just get both geometries. So we get the geom point, and then we get the geom smooth on top of that. And so geom smooth is just adding a smooth curve to our data. And so by default, I believe it's fitting a lowest line. We'll talk in a little bit about how to change what that line is, how that line is calculated. And it adds a standard error around it, which is the gray shading that you see. But each geometric object that you add is just another layer that's getting put on top of the plot. So as you think about like a plot in your head and like what all the different pieces are, the way you translate that to ggplot is just, okay, which layer is going to give me that information? And so that's what we'll see as we continue to go through our examples here. All right, so now we're going to talk about global aesthetics versus local aesthetics. So using our last plot as an example, you see that for both geom_point and geom_smooth, we're specifying the exact same aesthetics for both of these layers of data. And this is going to get really repetitive. So you can imagine like even more geometric objects that you might be adding to this. And so then you're copying and pasting that code over and over again. And then if you decide you want to change one of your variables, so say you wanted to put international gross on the y-axis instead of domestic gross, then you have to go in and change every single line of your code to use international gross. And that is really annoying and very error prone if you forget one of them. So what we can do is set global aesthetics. So in our original ggplot call at the top, that very first one, we can set aesthetics there using the same mapping argument. And so any aesthetic mappings that are defined in this top ggplot call are going to be applied globally. So these will get applied to every layer. And so you can see that the plot that we get here is the exact same plot that we got on the last example when we defined the mappings for each layer individually. And so when we have these global aesthetics, like we can still do local aesthetics. So here we've defined the X and Y aesthetics globally. Those are going to be used by every layer. But then for our scatter plot, our points, we can say that we want those to also have color mapped to clean test. And so that is a local aesthetic mapping. So the color is only being applied to our geom_point. It's not being applied to geom_smooth. So we can have both local and global aesthetics defined in our plots. And in addition, you can also have local data. This is less useful, but there are times when you might want to do this. So for example, in our geom_smooth, we can say we just want to use data from when the clean test has a value of OK. And that will fit a curve just to that section of the data. So you can have both global and local data. And so here in this example, like we've defined global data, but if you define something locally, it will overwrite whatever you've defined globally. And this filter function is one that we'll talk about this afternoon. So you'll learn how that function works. So you can have global and local aesthetics and global and local data as well. So you can really customize your plots to be whatever you want them to be. All right, so now we're going to talk about some stats or statistics for ggplots. So we have another quiz. So when we made our box plot earlier, it's giving us all these different values that go into the box plot. So it takes the median, the inner quartile range, it's calculating some outliers and the whiskers, but like none of those values are in our data frame. Like we just have the variables, like we are not giving ggplot those summary values. And we kind of already talked about this a little bit with histogram, but ggplot is doing a lot of these calculations on its own behind the scenes to save us some time. Similarly, for our plot that we were making earlier, so you've probably seen this when you made your geom_smooths. You got this warning message that said using method equals gam with the following formula. And so like, what does method gam means? So that stands for a generalized additive model, which we're not going to talk about. But that's just one method that geom_smooth can use behind the scenes to make this line. Like we're not giving it the values for that line, it's calculating it on its own. But we can change that, like we can define different statistics and tell ggplot to do exactly what we want it to do if we don't like the defaults. So we can define our stats. Like, there are several ways to do this. One is to use the stat summary function. So for example, we have our box plot and we want to add a point on the mean. So we can use stat summary, and we say we want to add a point. We want to use the mean, and we want to color it blue and make it big. And then we get a blue dot at the mean of each of these different levels of clean test on top of our box plot. So again, we're just adding that stat summary as another layer onto our plot. You can also use your normal geom. So we could add geom point and say stat equals summary, and the summary function we want to use is the mean. So by default in ggpoint, the stat is identity, which just means like, give me back the data. But we can change the stat that geom point is using, and we can tell it we want to use a summary statistic, and you'll get that same exact plot as we did when we used the stat summary function. So these are some ways that you can add your own summary to the plot. And again, like, these are just different ways to add layers to your plot. And both of these are going to do the same thing. So there's stat summary where you specify the geom, or you can do geom point and specify the stat. They're both going to give you the same thing. You can also plot distributions. So like, you can use geom function and tell it like which function you want to use. So in R, the normal curve, that function is called dnorm. So we can say we want to plot the dnorm function from -5 to 5, and that will then create this pink curve here, normal. And so here you can see one of the rare cases where you want to specify a color inside aesthetics that are not actually in your data. So like, if I say aesthetic color is normal, color is a t distribution, so you could do a student's t distribution, then it's making colors and assigning them to those levels, even though those levels aren't in the data. But you can also specify the student's t distribution and then compare those different curves here in your data. All right, so let's talk about some positions. So here is a scatter plot that we looked at earlier. We ended up turning this into a box plot, but there are a lot of ways we could look at this data. But this way is not very good. All of the points like right on top of each other. You can't really tell how many there are or what the distribution really looks like. So one way we can adjust for this is changing the positions of the dots, and we can use jitter for doing that. So we can say within geom point, like, we want the position to jitter. And so now we see like the points are all like jittered around a little bit. And we can now see that like, oh, there's actually a lot more in this no talk and in the OK than there are in the other ones. Like, this is a much denser distribution than we see for these other categories. But there are a few problems with this, so we can improve it. We can control how the jitter is happening. So we can say we only want to jitter the width by 0.2. So this makes it a little more, a little easier to see the distinct categories. You know, in this one, there's a little bit of space here in between, but like, it can get a little bit hard to see exactly which group each point belongs to. So we can lessen that width to make them more distinct. And we can also say, like, don't jitter the height at all. So like, each point will stay exactly on the y-axis where that data should be. We're only going to jitter along the x-axis to kind of get rid of the overplotting. So there are some ways you can play with the jitter to make sure that you can like increase the understanding of your data for whoever's going to be looking at the chart, without losing the accuracy that you might want to keep. What is the difference between this and geom jitter? There is no difference. Geom jitter is just geom point with position equals jitter. So you can use geom jitter for the same thing. It'll give you the exact same result. All right, so there are a lot of different positions that you can use. So position identity is just the normal one. That's going to put stuff exactly at the XY coordinates where you tell it to. We can add position jitter, which is the one we just talked about. There's something called position dodge, which is useful for bar plots. So the default in ggplot is to give you a stacked bar plot. Position dodge will put the bars side by side. If I remember correctly, I think there's an example we're going to go through where we look at that. You can also do position fill if you want, for again, useful for bar plots if you want all the bar plots to like sum to 100%. So if you're looking at proportions within groups, position fill is helpful. And there are more. There are a ton of positions. There are a lot on your cheat sheet. And then again, on the ggplot website, you can see all of the different options that you have. All right, so we're going to start with this plot. So here we have the decade code. So the number of films from each decade. Decade 1, just in case you're curious, is the 90s. Decade 2 is the aughts, so 2000 to 2009. And decade 3 is the 2010s, but this data, I believe, is originally from 2013. So it's not all of the 2010s, which is why there's so few movies in that category. So this is showing the number of movies within each clean test by decade. And so what we want to do now is add a position adjustment to this plot to compare the frequency of test results across decades. So like when we're looking at this, it's hard to really tell, like, were there more in this category in decade 1 versus decade 3? Because they're not lined up, it's hard to directly compare. So we want to take this code here and edit it to add a position adjustment. And you can ignore this, that should not be showing. I forgot to turn off that code chunk so that you couldn't see it. But we just want to add a position adjustment to this code. So take a few minutes to kind of explore that a little bit, and then we'll come back and talk about the answer. All right, so there are a couple ways that you can tackle this problem. One way is to do position dodge. So to that geom bar function, you can add position equals dodge. And that'll give you this plot. So again, now instead of a stacked bar plot, you have all the bars side by side. And this is helpful. You can now more directly compare each category across the decades to each other. Another option would be to use the fill position. So instead of position dodge, we can say position equals fill. And now we get a fill position where basically it's now proportion. So the proportion of movie in each decade that falls into each category. And so they all sum to 100%. So now you see the percent of movies that fall into each category within each decade. So either one of those will get the job done. Really about the, I guess the story that you're trying to tell with your data is really going to guide which one of those is going to be most appropriate for you in each situation. So again, ggplot is really just a very flexible tool set to help you communicate what you want to about your data. It's not going to tell you what the best thing to do is. Like that's going to require your own expertise and subject matter knowledge. But ggplot is just giving you the tools you need to make that happen. All right, so now we're going to talk about scales for a little bit before we break for lunch. So there are a lot of different scales within a ggplot2 beyond just like your x-axis and your y-axis. So for example, the color scale, like we can change which colors are being used. We don't have to use the ggplot defaults for that. So there are a lot of different color scales. For example, here we can call scale fill brewer. So the scale fill just means the fill aesthetic is what we're applying this color scale to. And then brewer is color brewer, which I believe we'll talk about in a couple slides. And if not, remind me, and we can go back to where you can find all the color brewer scales. They have a lot of different scales that are useful. This is the default. But you can change your palettes based on what type of data you have. So for example, if you want a qualitative scale, so there's no particular ordering to these, the default assumes that there is an order. That's why these are like semi and like a gradient. It's going from like the lowest to the highest. But if you don't want a gradient, you want them all to be distinct, you can say we want a qualitative scale, and it'll give you like 5 distinct colors that aren't in a gradient. There are a bunch of different palettes. Okay, so this is what I was hoping I had in my slides. The Color Brewer website, you can see all of these different palettes that they have. So sequential, again, is going to be that gradient-esque. So here's the greens. The blues that we saw earlier are the default. You can also do reds, purples. You can change to diverging. So if you wanted to go from like a low to a high, you can go from like red to blue. And then you have all the different qualitative scales that are available in here that are just distinct categories. And so you can specify within R whether you want, what type of scale you want, and then what palette you want. So like we've said, qualitative set 1. And so if we look under qualitative, somewhere in here, it'll tell you what the name of it is. I will candidly tell you that this is like not the most useful website. But if you look like up in the URL where we would always look for this information, it says set 1. And so you know that that's set 1 if that's what you're looking for. But yes, there are options to like only show colorblind safe palettes if you want those. And so then you can pick, so this one's called dark 2, paired, and then set to our 3 colorblind safe options. You can also use some other like non-color brewer palettes. This one is scale fill ordinal. So here we're telling ggplot that there is an order to these data, but it's not like a fully continuous scale. So it'll choose ones that are like kind of in a palette, like kind of in a gradient, but like not really. It just kind of gradually moves from one to the other. Okay, so there are, again, as with most things ggplot, there are a ton of options. So they all basically follow the same sort of like template. There's scale underscore whatever aesthetic you're trying to change, and then the type of scale you want. So we could do like scale color continuous, or we could scale color by a discrete variable, or scale color by an ordinal variable. There's also a manual option. So you could say like, I have specific colors that I want to use for like my brand. Like if I'm making a plot for my day job, like maybe I want to use like our company's like specific color palette. Or like I want to use KU blue and KU crimson. Like you can specify the exact colors that you want to use as well. And then again, you can use for only color and fill, you can use brewer, which we just looked at, or distill, which is another like color palettes. And then gradients are also for color and fill if you want to like go from like one color to another. We looked at some gradients in color brewer, like the ones they have built in by default. But again, you could specify your own colors to make your own color gradient if you wanted to. All right. So we can also do scales for our coordinate system. So we can change the scales for our X and Y. For example, here we use scale X discrete. So we're changing the X aesthetic, and we have a discrete variable on our X axis. And we can say the limits of our X axis are dubious, okay men, no talk, and no women, and it'll put them in that order instead of the default order that it has been putting them in. We also can do the same thing for our continuous variables. So we made this plot earlier. We have the budget on the x-axis and the domestic gross on the y-axis. But we can change this. So we can say the x-axis, we can set the limits. So like what's the minimum, what's the maximum value of our x-axis that we're going to allow. We can set the breakpoints. So by default, we just had the 5 breakpoints. Here we have a lot more than that. I used scientific notation when I defined the breaks because as much as I do not like it, as previously discussed, if you have all those zeros, the labels are going to start to overlap. And you can specify that. You can say labels scales scientific. So even if you specify them with scientific notation, because I have that turned off with SciPen, you have to specifically tell it to use scientific notation if you want to override your options. So you can change how your scales are working. All right, we still have a few minutes, so we'll talk about facets for just a little bit, and then we will always every day make sure to break for lunch at the right time, because I know people probably have other things scheduled for that time. But facets can be used to kind of break apart your data to see it in a little more detail. So for this plot, like it's helpful that all of the points are colored, but like it's really difficult to see what's actually going on here. Like if I asked you to describe like how does the like no women group actually compare to the OK group. Like, you can't really tell from this plot what's going on in those separate groups. But what we can do is we can add this facet wrap function. So we say facet wrap, and we want to wrap it by, in these variables, vars, wrap it by clean test. And so that's going to give us a different facet for each level of the clean test variables. And again, this would be better with scientific notation because you get the overlapping labels, but you get the idea of what facets can do for you. So now you see each group in their own little plot, and it's easier to see, okay, how is this group really different from the other groups? So faceting can be really helpful. You can also do facet grid if you want to facet by multiple variables. So here we faceted by one variable, but you could facet by multiple variables. So we say we want facets with the decade code on the rows and the clean test on the columns. And so now you can see here's the scatter plot for only movies in the no women category from decade 1, the no women category for decade 2, decade 3, and then places where no decade was specified. And again, the x-axis here is a mess. You can't read any of this. But there are ways we could fix that, and we'll talk about how to make your plot look a little bit nicer beyond just geometries and facets and stuff. All right, so that is a very quick overview of scales and facets. The next thing to talk about is themes, but I'm going to hold off on that until we get back from lunch. We have about 5 minutes. Does anyone have any questions about what we've talked about for ggplot2 so far? Happy to answer those now. Or we can break for lunch 5 minutes early. It's up to you guys. Does anyone have any questions? Not seeing any. I will go ahead and hang around for the next 5 minutes or so. If you want to hop off and go to lunch, feel free to do that. We'll come back at 1:30. I will leave the Zoom open the entire time, so you don't have to log out of the meeting if you don't want to, but feel free to log out and then come back at 1:30. The Zoom will be open, but I will probably not be here, so I'll be on mute, but feel free to throw questions in the chat and I can answer them when I get back. But as I said, I will be here for at least the next 5 minutes if you have immediate questions you want to talk about. Other than that, I will see you all back at 1:30. Have a good lunch. Welcome back, everyone. Hope you all had a nice lunch. If you just want to give me a thumbs up or a chat that we're all back. Awesome. Well, I hope you all had a chance to relax for a little bit. I did have one question come up while we were at lunch that I wanted to make sure everyone was aware of. And that is that I know some people are taking this workshop for course credit at KU. There was a question about like how that is being handled. Candidly, I did not know this was being offered for course credit until Thursday or Friday of last week. So there are no assignments or tests or quizzes or anything like that about like formal evaluation. It is really just attendance, participation, so like answering questions as they come up, but really it's just like, did you show up for the sessions or not? So that's all that is needed for your grade. So if you're worried about needing to do more than that, no need to worry. There's no sort of formal evaluation happening. Did anyone have any questions come up over lunch or anything before we get started? All right, well, we will jump into themes for ggplot then. So all of the graphs that we've made so far look generally like this. So they have like this gray background. They have like the x-axis and the y-axis that are the axis titles are centered. The legend is off to the right-hand side automatically, but we can change this. So this is just what it looks like by default. There are a lot of different themes that are built into ggplot automatically. So this is the default theme. It's called theme gray appropriately. There's also theme black and white. So we saw this one earlier in the previews of what we're going to talk about for ggplot. So this one gives us a white background with a black border around it. So it looks very similar, but just changing the overall look of it. And you add these by, again, just doing plus for a new layer. The themes aren't like really a layer. You're not putting anything on top of it, but that's just how ggplot works. You do plus and then whatever theme you'd like to use. So if you put theme gray here, it would give you the default look. But you don't have to specify that, obviously, but you can specify theme BW for theme black and white to get a plot that looks like this. There's theme minimal. So that just gets rid of some of the extraneous stuff that's going on the plot. So you no longer have that border around the outside. So makes things look a little cleaner if you like a simpler look. There's also theme void, which gets rid of everything except your geometric objects and your legends. This is not super helpful. For this type of plot, the axes are, I think, very useful. But if you think back to some of the examples we had at the beginning of this slide deck, if you're doing like a network graph that's showing all these different relations, the axes don't really make a lot of sense in that scenario. So that's a place where you might think about using theme void. And there are like many more different things you can do. So there's this general theme function where you can edit just about any aspect of a ggplot. So here we're specifying a new legend position. So this is still using theme gray by default. That's why we have the gray background still, but we can tweak individual pieces of it. So we put legend position equals bottom. And so now our legend is down here on the bottom of the plot instead of over here on the side. Again, in the ggplot2 website, which I will pull up again. So the reference page has all of the functions on it. And if you go to themes, you can see these are all of the themes that are built into ggplot. And then there's just like the overall theme function. And you can see there are like a ton, like you can get very granular in what you want to change. Like you can even change how the axis ticks look if you want to. So you can change just about any aspect of a ggplot that you want to just by tweaking the arguments to this theme function. And so again, you just make your plot the way you normally would, and then plus whatever theme you want to add. And there are also like theme packages. Like people have built extension packages for ggplot. One of these is GG themes that comes with just like more themes built in beyond like theme black and white, theme void. So for example, like in GG themes, there's a stata theme. So if you wanted to make ggplots look like they came out of stata, you could use scale color stata and then theme stata. And if you've ever been in stata, this looks very familiar to you. This is what a stata graphic looks like. So you're able to basically recreate any type of plot you want. And we could make this without the GG themes package. Like we could go tweak all of the individual theme elements to make this happen. But the GG themes package is really just like a convenience wrapper that contains a whole bunch of themes. All right, and so that brings us to ggplot extensions. So we've talked mostly about like what is happening in ggplot, but as I mentioned, there are a ton, just a ton of different packages that have been built on top of ggplot to add extra functionality. And not all of these will be useful to you depending on what type of work you're doing. But I think it's good to know that they do exist. So if you're trying to figure out how to do something in ggplot, one of these extensions probably is able to do what you're looking for. So there's ggforce. This just has additional geometric objects, additional stats, additional types of facets. So for example, there's facet zoom. If you want to like zoom in on a specific chunk of your data, you're able to do that. It also includes some geoms that will like outline different groups of points. And I can actually, I'll pull up this website to give you some examples of what it does. So here is the ggforce website. So you can like zoom in. So like here's like your full plot, and then facet zoom will zoom in on just this little area. So that's one example of what you get out of ggforce. Then there is ggrepel. So there's a lot of GGs in these names. But this is going to help with overlapping labels. So one geom that we have not really looked at today is called geom text, and then there's geom label that will actually put labels on your data points. But as you can guess, if you have a lot of data points and the labels start to overlap a lot, ggrepel helps keep them from overlapping so your plot stays readable. Then there is ggdist. If you do a lot of Bayesian analysis, or you have like a lot of distributional data, ggdist is really good for plotting distributions and summaries of those distributions. Again, the example that I use most often is like MCMC chains from a Bayesian analysis, but it is very useful in a lot of different contexts. Then there's also gganimate, which you can use to make animated plots. So you can show like if you have like longitudinal data and you wanted to show a scatter plot for each time point, you could make a bunch of different scatter plots, or you could make like one animation that shows how the scatter plot changes over time. So that's an interesting way to show your data if you're able to include animations. And then the last one that I'll mention is gggraph, which is used for network data. So if you have like a social network data, or you're plotting like some dendrograms or any type of trees, gggraph provides a lot of that functionality as well. All right, so the last thing that we have not talked about for ggplot yet is how to save the plots. So right now they've just been like populating in our R Markdown documents, but in reality, we probably want to save those out so we can use them in something else. Like you can insert it in like your Word doc or a PowerPoint slide, whatever you need it for. So there is a function called ggsave. So you can create your plot just as you normally would with your ggplot2 code, and then you call ggsave with whatever name you want to give your file once it's saved. And then you can specify the width and the height. And if you're doing that in inches. If you wanted to specify it in pixels, you could do that as well. And it will, by default, just save whatever the last plot you generated was, and it'll save it to your working directory, which for us would be that project folder, since that's where we've been working. But you can save specific things if you want to. So for example, you can do your normal ggplot as a g on point, and you can use this arrow operator to scatter plot. And that's just saying, take this plot and save it with this scatter plot name. Similarly, you can create a bar plot and save it with this bar plot name. And that's just saving it in R's memory. So like it knows if you say scatter plot to go like do what this graph was. And then for ggsave, you can again give it the file name and then tell it exactly which plot you want to save. And so we're saying here we want to save the scatter plot. And so R will go look, okay, this is what the scatter plot was. So save this ggplot as my plot.png. And you can also set the path. So you could save it to your desktop instead of your working directory. So that's how ggsave works, to save your plots however you would like them. So the big takeaway from this section is, I think probably Matt like summarized pretty well on this slide, which is just like a template for how to create a ggplot. Oh, there's a quick question. If you want to save several plots at the same time, as in a PDF or something. Okay, so let me pull up. That is not as easy to do, but you can do it. So ggsave, well, before I say this, I'm gonna make sure that I'm saying the right thing. Plot. Yeah, so ggsave will only do one plot at a time, but there are graphics devices in R. So let me get down here to saving the plots, and I'm going to pull up the slides. I'm going to copy this code really quick. Okay. Okay, so we have our code. So if we run this, we've saved that. You see nothing popped up because we didn't actually print the plots. We just saved them as these variables. And now if you look in your environment tab, you can see that we have a bar plot and a scatter plot. And if we look at the bar plot, then it shows it to us. Similarly, the scatter plot will show us the scatter plot. If we want to save both of these into a single PDF, R has what's called graphics devices built in. And ggsave is just like making it easier to use those. But the way you would do it is you'd say like PDF, and you see that it's like a graphics device. And so for PDF, you say like what the file is. So it'd be like myplots.pdf. And again, you can specify a width and a height. And then when you call this, it's just going to open up a PDF graphics device. So nothing happens. But then you can print your scatter plot, and you can print your bar plot. And if you run both of those, and then you turn your device off, oh, it doesn't want to shut it down. Why does it not want to shut it down? Did it make it? That is the question. So I think it's because I'm in an R Markdown document and it's trying to print things to here that it's not working. if we go to a normal R script, we'll see if this works. Yeah, so you can see it opens the device, it prints the scatter plot, and then it says device off. And it's, the null device 1 just means the device has been turned off. And now if you look in your files, there's this myplots.pdf. And if you open that, you now have both of your plots saved in this PDF document. So that's how you would save multiple files or multiple plots to the same file. And again, if you didn't want a PDF, like you could change this to a PNG, or I know like some journal articles want like a JPEG for their output file. So you could change that to JPEG and get JPEG images out. And then you would just need to also change your file extension. Oops. So this, like turning the device on, printing your plots and turning the device off is not super intuitive, to me at least, which is why the ggSave function exists. And so that is, it's a wrapper around opening and closing a device, but the constraint there is that it'll only do one plot at a time for you. But it is possible to do multiple. Another question, what does DPI equals retina mean? Good question. So DPI stands for dots per inch. And so DPI is controlling the resolution of your figures. So retina just means like, give me a high res image. You can also specify like how many you want exactly. So like 300 is like a pretty high res image. If you need a low res image because you need it to be like a smaller file size or something, you could specify like 120 dots per inch. But it's really just the resolution of the image. And some, like if you're making a graph for like a journal article or something, if you look at their authorship guidelines, a lot of times places will say like, we need images in like a PNG format with at least 300 DPI. And so like your ggSave, you can specify like, okay, I know I need this to be like a 300 DPI image. But that's just, it's the resolution of the plot is the short answer to the question. All right, so this is our like template ggplot function. So the way you basically make any ggplot is you start with the overall ggplot function, you assign it some data, and then you define any global mappings that you want to apply to every layer. So normally this would be like your x-axis, your y-axis, and then you add geometric objects. So your geom function, so like geom point, geom smooth, whatever geom you want to add, and then any local mappings that you want to add for that. So if you want color to be specific to this geom, you add that here. And then all of the stuff in blue is optional. So you could add an additional stat if you wanted to. You could add a position to your geom if you wanted to, but you don't have to. And then you can add facets, scales, theme functions. These last three are really just controlling the look of your plot, not necessarily like the geometric objects that are going onto it in the layers. So this is a template that hopefully is useful for you as you continue to make ggplots going forward. And then the last thing is to ggSave your plot if you want to keep it. All right, so that is a very quick and high-level overview of ggplot. We'll keep using ggplot as we go through the course. We won't really do any more like details about ggplot. So we won't be learning more about how ggplot2 works or anything like that, but we will be using it to create visualizations, especially when we get into the second half of the course with modeling. We'll make some plots to see like what our models are actually doing. But does anyone have any questions about ggplot, how you would do something, anything like that before we move on to our next topic? All right, I am not seeing any, so we will go ahead and find my next slide deck. Is the default for GGSave units in inches? That's a great question. I think the answer is yes. So GGSave, yeah, so the R help pages are not always helpful, which is good. So if you look at the help page for GGSave, there are a couple ways to get to the help page. So I did !GGSave, and that will automatically pull it up. In the help page, you can also just type GGSave in the search bar here, and that's another way to get to the help page. But then when you go down into the usage, it'll show you all the different arguments and what their default values are. So for units, you see that there's like a whole lot of default values. So when you see something like this, what it means is these are the only values you can provide. So GGSave will only do things in inches, centimeters, millimeters, or pixels. So if you try and specify something other than that, you'll get an error. And then whatever the first value is the default if you don't specify anything. So in this case, yes, the default would be inches if you don't specify anything. All right, so, oops, pulled up the wrong slides. We need data transformation. Oh, pinwheel of doom. All right. And again, all of the slides are on the course website if you want to follow along on your own. All right, so now we're going to talk about transforming your data, manipulating your data. And for that, we'll be using the dplyr package. And again, there is a chapter in the R for Data Science book on data transformation that goes into a lot of details on how dplyr works and how you might use it. We're going to cover the main points and what I think you really need to know in order to do almost all of the data manipulation you would need to do. There's obviously going to be some specialized cases, but this will cover, I think, at least 85% of what you would ever need to do. So again, I promised you would see this graphic a lot, and you will see it a lot. We're still in this little iterative cycle in the middle of visualize, model, and transform, but we're going to focus on the transform part for the rest of this afternoon. All right, and the data we're going to use for this particular set of slides is the baby names data. So there is a package called baby names, which has this data inside of it. So if you load the baby names package, you can then call baby names, and you'll see the data that looks like this. So you can see we have a year, you have the sex that was assigned to the child when they were born, the name, and then the number of children that had that name in that year. So for example, there were 7,065 girls that were given the name of Mary in the year 1880. And that was 7% of all females that were born that year were given the name of Mary. So that's the proportion column. As a very quick aside, before we get into dplyr, there is another package that's very useful for getting an overview of your data called skimmer, which skims your data and summarizes it. They give you different variable types, looks at distributions, etc. And so once you load the library skimmer, you can use the skim function, which is skim and then whatever data frame you want to look at, in this case, baby names. And it'll give you kind of a summary of what's going on in that data set. So go ahead and open this set of exercises. It's O3 transform in your exercises folder, and run the skim function on the baby names data set and see what kind of output you get there. All right, so let's see what we have going on here. All right, so first thing I'm going to do is go into, if you again hit this little R project, like our little cube up here, it'll take you back to the root directory of our project. And we'll go to materials, exercises, and this O3 transform. That'll open up our notebook for us. And the first thing that you'll always want to do is run this setup chunk. That's going to load the packages that we need for this particular set of exercises. So we'll run this, and that loads all of our packages for us. And then if we look at just the baby names, so if you only want to see the baby names, you can just come over here and say baby names. And again, we'll see just this data frame. So we can see, again, just like each of the individual rows. But if we do skim baby names, it's going to take a minute to think, and it's going to print out a not very pretty summary because my window was too small. I'll try again. Okay, that's better. And so here it's giving you a nice summary of what's going on in this data. So it gives you the total number of rows that you have in your data set, the number of columns. We have 5 variables. It's going to break it down by the type of variables that we have. So we have 2 character variables, 3 that are numeric, and we don't have any grouping variables right now. And then for each of the types of variables, it'll give you some nice summary statistics. So for the character variables, which are sex and name, it tells you how many of those have missing values and what percentage have data. So here, because there are no missing values, 100% are complete. It gives you the min and the max. Actually, I'm not sure what those are doing, but it gives you the number of unique values. So for sex, there are 2 unique values. It's male and female. And then you can see that we have 97,310 unique names across all of the years and the genders. And then for numeric values, again, you have the number that are missing and the number that are complete. So you can see we have no missing data in this data set. You get the average, standard deviation, and then you get some percentiles. So the 0 percentile is going to be your minimum value, 25th percentile, the 50th percentile is your median, 75th percentile, 100th percentile again is your maximum value, and then you get like a mini histogram of what your data looks like for those continuous variables. So that's what the skim function is doing. If you run it in your notebook with the play button, I think it'll spit it out in your, yeah. So it spits out your summary in your little down below code output area. And so it'll print you, you get 2 outputs. The first is this first line of code, so you get that output. And then the second output is your skim output. When I ran it, so there was no package named baby names. So if there's no package called baby names, are things that you have not installed the package. So if you do install .packages and then baby names, yes. So I got that error message because I was trying to install a package that I had already loaded. You can install the package baby names, it'll install it for you. And then if you do library baby names, you should be able to load it without an error. Awesome. Rebecca, did this answer your question about what's going on with the skim function? Were you able to get some output to run for you? Awesome, great. All right. So again, this was just the output of that skim function that we already talked about. All right, so we're going to talk about a few different things to do with dplyr. So the first function we're going to talk about is called select, and this is going to be used to pull out specific variables from our data. So we may not be interested in all of our variables, so select will help us look at just what we're interested in. Then we're going to talk about a function called filter, which is going to select only certain rows of data. So if we want to exclude some data from our analysis, we'll learn how to do that. And then we'll look at a range, which is going to sort your data frame. If you're interested in looking at just the highest values or just the lowest values, a range is what's going to help us with that. So we'll start with these 3 functions, and then we'll move on from there. So we're going to talk about select first. So select is going to take 2-ish arguments. The first is this .data. That's going to be the data that you want to transform or your data set. And then you send it the names of columns that you want to select. So this can be 1 column, it could be multiple columns. It's really up to you and what you need. So for example, if we did select baby names, name and proportion, it would take the baby names data, which here is like the first part of it. It would select the name and proportion variables, And so we'd get a data frame back that just had those two columns in it. All right. So now what I would like you all to do is take this code. You can copy it into your notebook if it's not already there, and edit it so that it's selecting just the in column instead of the name and proportion column. All right. So to make this happen, instead of baby names and then name and prop, we instead just say select from baby names the in variable. And this will give us just the in back. Was everyone able to make that happen? Awesome. All right, so we are going to come back to baby names in just a little bit, but for the next couple exercises, we're going to use another data set called storms. And the storms data contains data about hurricanes. So this includes the year, month, day, and hour of the report. So when it was made, the position that's the latitude and the longitude, what the current status of the storm was. So for example, like all of these rows are for Hurricane Amy back in 1975. And so you can see that there's data from like every 6 hours. And so you can see like where Hurricane Amy was at each of these time points, what the status was. So here at the beginning, it was a tropical depression. And you get more data about the storm. So you get like wind speed, air pressure, the diameter of the storm, all types of information about these hurricanes is in this data set. And I want to use this so that we can talk about some select helpers. Our baby names data is pretty small. There's only 5 variables in it, whereas this has more variables, so it's easier to see how these selectors can be helpful. Because if you have a lot of variables, it can be annoying and cumbersome and error prone if you try and type out every single one of them. So for example, we can use the colon. Let's say from the storms data set, name colon pressure. That's going to give you every variable between name and pressure. I'll actually pull up my examples here to show you how these work. So I'll run everything to make sure I loaded my packages. All right. And so again, if we look at this storms data, storms, we get all of these. And then if we say storms, but just name through pressure, so it'll start with name, it'll give us everything until we get to this pressure variable, which means we'll lose both of these diameter variables. So if we run that, we can see that we, down here, we have name all the way through to pressure, and then there's no more variables after pressure down here. The next one is the minus operator. So this is used to remove variables. So here we say we want the storms and we want to remove, and then this C function. So C, and then there's parentheses wrapped around name and pressure. That just means multiple. So it's like put these two together. So we want to remove the name and the pressure variable. So again, if we run that and see that in our data down here, we now no longer have that name variable at the beginning. And if we scroll through, we no longer have the pressure variable after the wind speed. It has been removed. There are also some helper functions. So you can say starts with. So if you select from storm anything that starts with W, you can run that, and wind is the only variable that starts with W, so that's the only one that comes back. This can be good if you're working with, for example, like survey data out of Qualtrics, where like all the questions are like Q1, Q2. If you wanted just the question data, you could say just grab anything that starts with Q, and that also give you those variables back. Similarly, you can use ends with. So here we want anything that ends with an E. So that's going to give us name and pressure, are our two variables that end with E. There's also contains, which is going to look for a character string anywhere in the variable name. So here we'll get any variable that has a D in the name somewhere. So we get day, wind, and then the two diameter variables. Matches uses regular expressions. Regular expressions are a way of matching character strings in a like programmatic way that like is not super readable. Like it is not very clear if you don't know regular expressions what this is doing, but it can be helpful if you have like a complicated pattern that you're trying to match. So for this example, the way this regex is working is it's saying take any character name that's going to start, it's going to have a character at least 4 times, and then it's going to end. So like it would not pick up day because day is only 3 characters. So if we run that, we then get all the variables that have at least 4 characters in their name. In practice, like this example is probably not very helpful. Like you're probably not often looking at, okay, give me the variables that have longer names. But if you're trying to match like a pattern followed by another pattern, regular expressions are really helpful. We're not going to talk a lot about regular expressions, but that's the keyword to Google is regular expressions if you're looking for a complicated matching pattern. And then the last one that I want to point out is any of, and there's a similar like sister function called all of, and it will pull out it will pull out any variable that matches these names. So we could say name, names, or name. Give me any variables that match those. So here we get just the name because there is no names or capital name variables. So we get just what we wanted back. If you use all of, this means that it is going to require that all of these be present. And so you'll get an error because names and capital name do not exist. So if you are wanting to do like some data checks where you know like these variables should be in my data set for me to proceed, then you might want to use all of so that you get an error early to know that this is why my things are not working as expected. So those are our helper functions for helping us select variables. And these are summarized in the data transformation cheat sheet. So just like there was a ggplot cheat sheet, they're in that same handouts folder. There's a dplyr cheat sheet. And on it, there's this select helpers that summarize these different helper functions that you can use. Right, so we have another, I guess, not pop quiz, it's a consider. Really changed my naming up here. So which one of these would not select the name and the in columns together? If anyone has a guess or an idea, go ahead and throw it in the chat or feel free to take yourself off mute. Yeah, it's the last one. So this first one is going to remove every column except the name and in. Here, name and in are the first two columns, so we can use the everything in between. They both start with in, but they do not both end with in, so this one would not work. And again, this is all the different options. Again, and they're all giving you the exact same answer except for option 4 will only give you the in column. It will not give you name. Awesome. So that is select. So now we'll move on to filter. So whereas select was picking out different columns, filter is going to pick out different rows for us. So just like select, this has a very similar feel to it. You say filter, you give it the data that you want to pull some rows out of. And then instead of columns, we're going to give it some logical tests. And we'll talk about what those are in just a second. But then filter is going to return each row where the test is true. So for example, again, with our baby names data, we can say filter baby names to every place where name equals Ida. And so the way we specify that in our code is we say name equals Ida. As you can see, there's one example of where it's pulling Ida from. And what we get back is this data frame that only has Ida names. So you can see in 1880, there were almost 1,500 females that were named Ida and 8 males that were named Ida. So this equals operator is what's doing the test for us. So it's deciding is the name variable equal to this string value of Ida that we've given it. And so there are a lot of logical tests that you can do on your data. If in your R console you type ? comparison, it'll bring up the help page for all of these logical tests. I've put the main ones here. So there's less than, greater than, the equals is equal to. You can do less than or equal to, greater than or equal to, the exclamation mark followed by equals sign is going to be not equal to. You can do this percent in percent, and that's saying that X is in some group of values. So Y would be like a set of values, and it would say, is X in this set of values? Then you can also do is in A of X, and it'll tell you whether X is missing or not. And then you can also, again, add that exclamation point. So just as up here, the exclamation point meant not equal, here the exclamation point is not missing. So it is not in A. So pull only the rows where X is non-missing. All right, so now with those logical operators we just talked about, what I would like for you to do is filter the data in 3 different ways. So first, filter the data to only include cases where the prop variable is greater than 0.08. The second one is filter the data to only children named Daenerys. And then the third one is filter to only places where N is missing. All right, so I'll give you a few minutes to work on that, and then we'll come back and look at the answers. All right, so let's look at how we would tackle these. All right, so if we want places where all of the prop is greater than 0.08, we're going to say filter baby names. And then we want prop to be greater than or equal to 0.08. And that'll give us 3 rows back. So you should get these 3 back. Looks like John and William were very popular names in 1880. And those are the only places where more than 8% of a gender was given a single name in a year. Then for the next one, we want all of the children named Daenerys. So again, we say filter baby names, then name equals Daenerys. So again, we can see that probably not coincidentally, this name didn't start showing up in the data until 2012 when Game of Thrones started airing. So that makes sense. It's not, I would say, a very common name outside of there. But you can see this is when the name started showing up. And then for the last one, we want places where the value of n is missing. So we can say filter baby names and then is NaN. And we get 0 rows back, which is what we would expect. If you remember when we were looking at the skim results earlier, we saw that we had no missing data in our baby names data frame. So we would expect when we filter to only rows that are missing, we get no rows back because nothing's missing. Okay. So we are, it looks like right at our break. So let's take 15 minutes. We'll come back at 2:45 and we will look at more ways to filter. So we'll look at filtering on multiple conditions instead of just one condition when we get back from break. All right, so let's take 15 minutes and be back at 2:46 Central Time. All right, welcome back for our last home stretch through the afternoon for day 1. So before the break, we were looking at different ways to filter our baby names data, but we were focused on like one logical test at a time. So one condition, but we can do more than that. Just like we could select multiple columns, we can filter on multiple conditions. So for example, if we say we want baby names, but filter to where name equals Ida and year equals 1880, then in that case, we will only get the rows that meet both of those conditions. So in this case, we would get only 2 rows back, one of females named Ida in 1880 and one with males named Ida in 1880. And so this like and logic of doing name and year in programming languages is kind of it's called Boolean operations. So Boolean just means true and false. If you do question mark base logic, you'll get the help page for all of these. But these are the main ones right here. So you'd use the and sign to do and. So it's condition A and condition B. The straight up and down pipe is or. So if it meets either one of the conditions, then we'll keep that row. XOR is specifically where one is true and one is false. So the normal OR is keep it if one or both is true. The XOR, or exactly OR is what XOR stands for, is exactly one of the two is true. Again, that exclamation point means not. And again, the percent and percent can be used for group. So if A is in that group of AB, which in this case it is, we would keep that row. All right, so now we're going to try some of these Boolean operators out with filter. So I want you to again filter the baby names data set in a few different ways. In the first one, we want to filter to only females that are named C, like C is like the ocean C. 2 is names that were used by exactly 5 or 6 children in 1880. And then the last way to filter the data is names that are one of Acura, Lexus, or Yugo. All right, so we'll give a few minutes to work on those, and then we'll talk about the answers. All right, so there are a few ways to do each of these. Again, there's not necessarily a right or wrong way to do it as long as you get to your answer. So we'll go through a couple ways you could do each of these. So we'll start with females named C. So one way would be to say, give me cases where name equals C and sex is F for female. And that'll give you these two rows. So we can say that girls were only named C in 1982 and 1998. Alternatively, instead of the comma, you could say and. So you could be explicit and say we want name equals C and sex equals female, to just be like extra explicit that you're using and. However, that is the default. Like if you're just separating by comma, it's going to give you that and as well. So either one of these will give you the same answer. All right. So next we wanted places where the number was either 5 or 6 and the year was 1880. So here we say we want n is in 5 or 6. So it's in this set. Only give us places where n is in this set of numbers. And the year is equal to 1880. And so this should give you 455 rows. And again, you'll see each of these has only places where n is 5 or 6 and year is 1880. Alternatively, you could use the or operator. So you could say, give me places where n equals 5 or n equals 6. And you have to wrap that in some extra parentheses. And the year is 1880. So you can write it in this language. It'll give you the same exact results. We get those same 455 rows. But that is a way to use the or pipe operator as opposed to the set. I tend to prefer this sort of notation. That is clearer to me and I think a little more concise than spelling out each condition individually. But if you prefer to see each condition individually, this is perfectly valid R code that will give you the exact same answer. All right, and our last filter was on cars. So babies' names where the name was Acura, Lexus, or Yugo. So again, I prefer this sort of set notation where it says, give me cases where the name is in this set of values. And so we see there are 57 cases where children received one of those names. However, you could also say, give me places where name equals Acura, name equals Lexus, or name equals Yugo, using those or operator bars, and that will give you the exact same results. For me, again, typing name equals 3 times is less annoying to me than typing it once and then just the set of values. But either one will get you to the correct answer. All right, so that is filter. So now we'll move on to arrange. So just like arrange or just like select and filter, arrange has these two sort of arguments. The first one, again, is going to be the data that we want to arrange. And then these dots are going to represent the columns that we want to order by. So the first column you specify is going to be what you order by. And then if you provide additional columns, those are used as tiebreakers. So if multiple rows have the same value for that first column you're ordering by, the second column would then be used to order them in the tiebreaker. So the way that this works in practice, when we have our baby names and we want to arrange it by N, so it starts out all out of order. And then once we arrange it, it's now sorted by N. And by default, it gives you the lowest value first to the highest value at the bottom. All right. So now we'll play with arrange for a little bit. What I would like you to do is arrange baby names by n, and then add prop as a second tie-breaking variable to arrange by. And then once you have that, look at what the smallest value of n is in the data. All right, so for this one, again, we do arrange. We're arranging the baby names data. We're arranging it by n, and then we're using prop as a tiebreaker if two rows have the same value of n. And what we get back should be something that looks like this, where you get the rows sorted by n. So we see the smallest value in our data is 5. And then the proportion for that year. And so what you see is this doesn't actually include every baby name from the United States. It's only including cases where there were at least 5 names or 5 children born with that name in the year. So one good reason to explore your data is you find things like that it doesn't actually include all of the babies that were born. So another thing we can do is change how the data is sorted. So by default, it goes from lowest to highest, but we can change that with the descending function. So it's DESC. So if we say arrange baby names by descending n, then we get the same sort of sorting happens, but instead of lowest to highest, it's going to go from highest to lowest. So you're able to control how that ordering is happening. So again, we'll use this descending function to find the names with the highest proportion. And then also look at which names have the largest values of n. So 2 different ways to arrange the data. We want to find the highest proportions and the highest n's. All right. So for proportions, again, we say we want to arrange baby names descending by proportion. So these are the highest proportion baby names. Again, a lot of Johns and Williams, which you might expect. And then for ends, we can similarly arrange baby names descending by n. We can see that there were almost 100,000 Lindas in 1947, but that was actually only about 5% of the girls that were born in that year. So, all right, so that is arranging. And now we're going to talk about something a little bit different, and that's this pipe operator. So it's percent greater than percent. The reason that's going to be important is for this question. So say that you have the baby names data and you want to combine the different functions that we've been looking at so far. So you want to do some filtering, you want to do some arranging, and maybe you also want to remove some data. So you have the baby names data, and what you want is this like final answer over here on the right. So how would we go about doing that? There are a couple ways to do it. The first way is what I would call nesting. And so this is gonna like nest your functions inside of each other. So we start with baby names and we say, okay, we want to filter baby names to only have the name that is within the set of stanza and aria. And after we filter it, we want to arrange it. So we're going to arrange like this that we just did. We're going to arrange that by name and then by year. And then after we've done that, we want to select from this answer, remove the proportion variable. And so your final answer is this like very long string of code that I don't know about you, but for me, this is like not very clear. It's hard to tell what's actually going on and what this code is supposed to be doing. So this would be not ideal. Another way to go about tackling this problem would be through intermediate objects. So we could save the baby names data as an object in R. We can call it bn1. And then we can say, okay, we're going to filter bn1 to only have names that are stanza and aria, and we'll save that as bn2. Then we'll take bn2 and we'll arrange that by name and year, and we'll save that as bn3. And then finally, we'll take bn3, remove the proportion variable, and we'll get bn4. So that's another way. It's perfectly valid R code. It will get you to the answer, but also is not super clear. You have all these intermediate R objects, which are all going to pop up in your environment window. And then eventually you have to remember, okay, which one of these did what? Which one do I actually want to be using? And it's also not clear, depending on how your code is structured, like where the pipeline begins and where it ends. Like, is there a bn5 somewhere? Like it's not really clear from this type of code whether there is a bn5 or not. And so the principle that I would suggest is that your code should be telling the story of what you're doing to the data. And for the sake of time, I'm not going to make us all listen to Dolly Parton's 9 to 5. If you're not familiar with the song, I highly recommend it. But I'm going to use the lyrics to kind of demonstrate how I think the code should be working. So the code should tell a story. And so at the beginning of the song, she's saying she first tumbles out of bed, stumbles to the kitchen, pours myself a cup of ambition, yawns, stretch, try to come to life. So this is the steps in the process of what's happening in the story. So if you were to write that in code, this would be like the nesting functions version of that. And so if I just gave you this code and I said, what story does this tell? Like the answer is probably, I have no idea. Like this is just like a mess of functions to me that like I can't even really tell like where it starts. So this is not clear if you're trying to like collaborate with other people, including future you. Like if you write this code today and come back to it 6 months from now, you probably do not remember what this is supposed to be doing. So what we want to do is turn the story into code. So we start with I, and we're going to take I and we're going to tumble out of bed. And then we stumble to the kitchen. We're now taking all of that we've done so far, and we're going to pour myself a cup of ambition. We're going to take all of that and we're going to yawn. We're going to stretch, and then we're going to try to come to life. So if we write it this way, like we understand what this means right now, but others will not remember in the future. And this is where this pipe operator is really going to save us and make our code much more readable and understandable. So what the pipe does is it passes the output of one function to the first argument of the next function. So if you have code like this, it's taking like me1, passing it to the next function, and then it takes me2 and passes that one to the next function. And so the way we do this with the pipe is we say I pipe tumble out of bed and pipe that to the next function. So we're taking each output and just passing that to the next action in our pipeline. And so this really allows you to tell more of a story with your data. So this, to me, at least, is much more clear as to what's going on. You're starting with your object I, then you're going to tumble out of bed, then you're going to stumble to the kitchen, you're going to pour yourself a cup of ambition, yawn, stretch, and then try to come to life. So this is a much clearer way to write your code to see what exactly you're doing and in what order you're doing it. So now, like, let's talk about how we would actually do this in the tidyverse. So these functions are all built, as you might have picked up on as we were going through these first three, the same way. They all take a data frame as their first argument and then some other number of arguments after that. So we can pipe the output of one to the input of another. So a better way to accomplish the same goal would be to use piping. So we would take the baby names, and we want to take the baby names and we want to filter that to names are in Sansa and Arya. We want to take the output of that and pipe it into arrange. We want to arrange by name and year and pipe that to select and remove proportion. And so you get the same answer as you did with our two other options, which were nesting in the intermediate objects. But this is much more clear as to what's going on. You can see each step, what's happening, and you know that this is the whole pipeline because it has a beginning and then it has an end where the pipe stops. Okay, so now I want you all to use the pipe to write a sequence of functions that's going to take the baby names data, filter it to just females that were born in 2015, then select just the name and the end columns, and then arrange those results so that the most popular names are at the top. And I realized I did not put a clock on this slide. So we'll do like 3 or 4 minutes to play with this one, and then we'll come back and talk about the answers. All right, so let's look at how to go about doing this. I'll pull up my own code here. All right, so we'll start with the baby names. We then want to filter it to just females and the year equal to 2015. The next step we want to do is to select the name in the n columns. And then we want to arrange so that the most popular names are near the top. So we'll do descending by n. And that shows us that the most popular female names in 2015 were Emma, Olivia, Sophia, and Ava. All right. Was everyone able to get the pipes working? Yes, good, good. All right. All right, so now we're going to combine our skills. So we're going to do dplyr and ggplot together. So what we want to do is take the baby names and filter that to only have the rows that have your own name. And then we want to make a plot that's a line graph that has the year on the x-axis and the proportion on the y-axis colored by the sex variable. So you're going to take your dplyr code that we just learned to make a data set that has just your name with the year, proportion, and sex variables, and then use that data to create a plot using ggplot. And again, I don't know what happened to my clocks here, but we'll take another 3 or 4 minutes to work on this, and then we'll talk about a solution. All right. So I will use myself as an example here. So we're going to start with our baby names data. We want to filter that to only places where the name equals your name. So I'll do Jake. Then we want to select just the variables that we need for our plot. This is not strictly necessary, but I think is good practice. And so if we ran just this code, we can see data. So this is only places where the name is Jake, and you can see the proportion of people that were named Jake in each year. And now we want to send this to ggplot. And if you remember, the first argument to that main ggplot function is our data. And so we can just pipe this straight into ggplot. So we can say ggplot, and then our mapping is going to be that x is going to be the year variable. And then on the y-axis, we want that proportion variable. And we can add a line. And then again, we're going to map the color to the sex variable. And so now if we run this, we get a plot that shows the proportion of both males and females that were given the name of Jake over all of the years in our data set. So hopefully everyone was able to get a nice looking chart for their own name. And hopefully you're starting to see how these different pieces of the tidyverse start to fit together. So we can pipe directly from dplyr to ggplot, and it all just kind of works together. And that's hopefully what you're going to continue seeing as we go through the rest of these packages throughout the week, is they all do different things and they all do their own distinct thing, but then they all kind of come back together to make one cohesive data science or data analysis environment within R. All right. So we are right up on time for today. And I want to make sure that I get us all out of here in case anyone else has meetings this afternoon. So we'll go ahead and stop here for today, and we'll pick up with trying to figure out which names are the most popular. We'll use some new dplyr functions for that. So we'll pick up here tomorrow morning. So we didn't get through all of these slides today, but that's fine. We'll pick up some time later in the week with some topics that I don't think will take as long as they're budgeted for. Does anyone have any thoughts or questions about what we've done so far today before we call it an afternoon? No? Awesome. Well, thank you all for hanging in there today. I know these days can get long, but hopefully you're all finding the material useful, and please sign up for office hours if you have questions throughout the week. And on that, I will post the recordings from today as soon as I'm able to this evening, and I will see you all tomorrow morning. Thank you.